All right, so today we're going to learn about solving systems of equations using substitution. So this is very useful because we don't always, when we graph, sometimes the answer isn't completely accurate, okay? Or it's hard to find an answer that is exact. But when you solve using elimination or substitution, which is what we're going to do today, and there's three different ways there's like 4 different ways or 5 different ways to solve systems. And a system means more than one equation. So basically, you're figuring out where these 2 lines cross when we solve a system. So in the first case, I'm going to take the lines y equals negative 4x plus 8, and the line y equals x plus 7. And I want to see where those 2 lines cross. So an easy way to do this is to use substitution. And substitution means just what it sounds like. You take one thing and you put it in for something else. So what I do is, since this says y equals, and the other equation says y equals, and what I'm trying to find is where y is the same in both cases, I take this and I put it in there for y. Alright? Now when I do that, and the reason I do that is I end up with an equation that only has one variable. So x plus 7 equals negative 4x plus 8. Once we have that, did I unpause? Or recording?
Yeah, good.
Right? So how do I solve this system of equations? What do I do? What should I do first? Come on, guys. Help me out here. You know what?
Oh.
I want to change something just to make this one work out easier. I'm going to change this to a minus sign, just so it comes out. They won't always come out nice, but in this case, it's going to come out nice. Okay?
Hey, I have a question.
Now,
Don't you have to change the other one to a minus?
yeah, I have to change it over here to a minus. Okay? Change that to a minus because I want this one to come out nice. That's a minus sign. So how do I get this 4x onto this side?
Oh, plus 4x.
Plus 4x. Remember we did this? You get all the x's on one side.
Now you have 5x plus 7 equals
That's
negative
right.
8.
Hey. We have 5x plus 7 equals negative 8. Now I want to bring this 7 onto the other side.
Minus 7.
Minus
equals
7,
5x equals 15.
minus 7, minus 7. And I get
Divide by 8.
5x equals negative 15. And then what?
Divide by
5.
Negative 3.
Divide by 5. And I have x equals negative 3. Now I'm not done yet, because when I find a point where they cross, I have to find both x and y. So what I do is I take this number, negative 3, and I plug it into either one of my 2 equations to find y. Which one would be easier to plug into? This one or that one? Which one's easier to plug into? You guys don't have any opinion on that? Which one, Elise? The second one, right? It's easier to take that negative 3 and just plug it in there. And when I do that, I get y equals negative 3 plus 7, which equals 4. Guys, so you're not done until you find both x and y. So the point where those 2 lines cross is negative 3, comma, 4.
And that's how we want you to write it. You want to put it in an ordered pair, because that's your
In an
solution.
ordered pair. This is x, and this is y. So again, if I wanted to graph these, right, let's just say, you don't have to write this down, but if I were going to graph these 2 lines, if I were going to graph these 2 lines, let's see, negative 4x minus 8 is going to be some line that's steep and is going through here, like down through negative 8, right? And the other line is y equals x plus 7. It's going to be going through 7 and up here, right? Kind of like, and it's going to have a slope of 1. So it's going to cross like that. And then I'd have to find that point of intersection, right? And that is that point right there. But it's easier and more accurate to do it by algebraically. Okay? So that's how you solve a system using substitution. Let's do another one.
Cool.
Cool. Isn't that great? Let's use, let's do this. Okay, so the next, let's do another one. Do you guys want to try one? You guys try.
Not yet.
Yeah, try. Okay? Yeah.
Okay, let's see what we can do.
Y equals negative x plus 3 and y equals 2x minus 6. I'm going to pause. Your
Well, how'd you
first
do that?
step.
You did the exact same thing that I did that.
I moved 2x minus 6.
Okay, so she did this, right? And then what?
I put the x's on the
How did you do that?
added an x to both.
She added an x to both sides. Yep. And she gets and then what did you do?
I added 6.
She added 6 to both sides. And she gets 3x equals 9. And
Where
then
did you get the 7?
divided by 3. Okay?
Not the
Oh,
problem.
that's
And I
cool.
get x equals 3. And then what do you do with that 3?
I moved 3 to y equals 2.
Well, that
And
explains
she
everything. I put a
spread.
7 instead of a 3.
Okay. And then she took that and she plugged it in there and she got y equals 2 times 3 minus 6, which is 0. Guys, so there's our y. So she got 3, comma 0, and that's your answer. Yeah,
Cool shoes.
record. Yeah, so
Shoes.
to do this, I need to substitute. I'm still going to substitute.
There you go.
And my goal in substitution is to get one equation that has just one variable, either all x's or all y's. So does anyone see something I could plug in over here to get an equation with just one variable?
Minus 7x times negative 1.
Oh, what? I can take, since y equals 2x, I can take that 2x and put it into that equation. Okay? So now what I have is 7x minus 2x equals 15. What's 7x minus 2x? How many x's do I have altogether? 5 x's, right? 5x equals 15. Divide by 5. I got x equals
3 comma 6.
3. Okay? Now I have to take that number and plug it into probably this one, because this one's already set up to find out y. This is the easier of the two equations. Plug it in there, y, and I get y equals 2 times 3, which is what, Michael? 6. So now my answer is 3, comma 6. And just to check, let's take both of those numbers and plug them in here. If I take 3 and plug it in there, and 6 and plug it in there, do I get 15? Let's see. 7 times 3 minus 6 equals 15. Is that a true statement?
Yes.
7 times 3 is 21. Minus 6 gives you 15. 15 equals 15. So you should always take your answer and check to make sure that it works. Right? So I have 3y 3y plus 2x equals 4. And then I have another equation that is minus 6x plus y equals negative 7. Now, here's the problem. I don't have a y equals to substitute with. Okay? So my first step that I have to do is I have to get y by itself. Now, this is probably not the best method for solving this particular problem. We'll learn another method next time in a couple days. But first I want to get y by itself in this equation. So how could I get y all alone? Over here. Mary, how can I get y by itself in this equation? I want to get y by itself. Add something. Add 6x to both sides. Plus 6x. And so usually you kind of want to put this 6x in front of the number. So y equals 6x minus 7. Now what I could do is take this y equals and plug it into my other equation. Okay? Because you have to take one equation and plug it into the other equation. See that? Now this gets a little tricky because what you have to do is you have to distribute first 3 times the quantity. So I'm plugging in for y. So I'm plugging in 3 times 6x minus 7 plus 2x equals 4. Do you guys understand where I got that from? Okay. So now I distribute. You can't forget to distribute. 3 times 6x is how many x? 18x. And 3 times negative 7, negative 21, plus 2x equals 4. So now what I'm going to do is I'm going to combine this term and this term. How many x's do I have altogether?
20.
20x minus 21 equals 4. Now what? Now what, Sam? Now what?
Do minus, do you
Not-
add 21?
Add 21 to both sides. So I'm going to plus 21, right? Plus 21, which gives me 20x
Put the wrong numbers in again. Equals 25.
equals 25. Now, unfortunately, fortunately or not fortunately, I'm trying to show you a good problem which doesn't come out nice and neat. Divide by 20, divide by 20. And so what I get is x, this cancels out, and going up here, okay, I get x equals 25 over 20, which reduces to, what goes into both of those numbers?
1.25.
5.
5 over 4, which is 1.25 if you want to write it as a decimal.
Check.
Okay? Now, I'm not done yet. I have to take y, or x, excuse me, and plug it in for y. But rather than plug it into one of these, because that's kind of a, then I'd have to solve for y, which is, I'm already solved for y over here. So I'm going to take that and plug into this more simplified form of this equation and plug x in there. When I do that, I get y equals 6 times 1.25 minus 7, or y equals 6 times, I think that's 7.5, is that right? 6, if you have 6 quarters, that's $1.50.
7.5.
7.5 minus 7, so y equals 0.5, okay? And so when I write this as an ordered pair, I write it as 1.25, comma, 0.5, or 1 1/4, comma, 1/2. Okay? Now, that shows you that like these two lines, I'm not exactly sure what they look like. Y equals 6x minus 7 is going to be a steep line going like this. And this is going to be y equals negative 2/3 x. That's going to be a line kind of going like this over here. And that point would be really difficult to find using graphing, right? But here you're finding an exact answer using algebra. So that's why this method is very important for you to know. We should write down some of the steps that we do when we're doing it. First step, I don't want that. First step 1, I would say solve for y in one equation. Okay, if it's not solved, most of the time you'll have y equals something, right? Okay. So solve for y in one equation. If it's already y equals, then you don't have to do that. Okay. 2, you want to substitute in for y in the other equation. Okay.
This could be for x too.
Yeah, or x in the other equation. Very good. Thank you. And the other equation. 3, I would say, substitute in for y in the other equation. 3, distribute if necessary. Distribute if necessary, only if you have to. Is that how you spell necessary? 1C? Okay. 4 is solve for x. Or y, if you plugged in for y, but we didn't talk about one. And 5 is plug into the easiest equation. And the equation
Plug x into the easiest.
plug x into the easiest equation to find y. And then we would say, write your answer as an ordered pair, right? Write as an ordered pair. Ordered pair with meaning x then y, like that. And lastly, check your solution. Check. Check? Checky? Checky. I don't want checky. I want to just check. By plugging in x, and y to at least one of your equations. To original equations. You should really check both, but that's kind of a whole ton of steps. But that's a lot of steps, right?
Label the steps that they're steps first.